There are some limitations. So we have Agentic AI, we are bringing in so many bots, agents together and then work on it. So what happens? One of the main thing is the task drift. So task drift is here. What happens is because there is a long chain of action. So let's say the process is keep on dividing, right? So there will be a lot of tools to be accessed and everything. So what happens day by, you know that there is a LLM models or stateless. So we need to maintain the state as well. So many things, many challenges will come in, and as the day go by, the LLM will start to hallucinate because it is seeing a lot of information and the task is being getting complicated. So it slowly the task drift happens, and then one or two bots fail. It will also incur, it will be a collapse of the entire agentic AI tool. So let's say one of the bot gives a wrong information, or it is hallucinating. So there will be a collateral impact on the entire agentic AI systems. So that is the problem this current agentic AI, where we are bringing in all the bots and putting a manager in place. We need to standardize because let's say one agent is accessing a certain tool and then it is responding in a certain format, let's say in XML format, whereas another agent is receiving in a different format, let's say in a JSON format. So there will be a conversion taking place. So there is no standardization of the communication between the agents and within the agents. So this involves a lot of issues and complications will happens if you bring in more bot or if you are automating a bigger process. And also when we talk to developers or software engineers, the debugging of a complex agentic system, that is very hard to do it because there are a lot of things and lot of information, lot of prompts goes in. There is no standardized way, and it is very difficult to find where the issue is happening. So all these things are limitations and challenges in a very simplified AI agents. Then there need to be a standard which standardize the entire communications between the agents. So that's where the MCP comes in. It is Model Context Protocol. Okay, so so this is actually developed by Anthropic. So you know the Cloud A model, right? So the developer of Cloud A model, Anthropic, they brought in this MCP protocol. There are different protocols, A to agent protocols, etc. That is a communication between the agents. So this is the MCP protocol, and so this simplifies a lot of things. Before MCP, as I told before, each of the LLMs, each of the agents will have their own set of tools, own set of memory, planner, etc. So you need to wire them again and again, and then you need to create a centralized memory and bring all the memories inside it, right? So this is a cumbersome process. So imagine you have a 10 AA agents. Every time you cannot go and modify the AA agents. What happens if a API fails? So what happens if a API is changed? Now you need to identify the AA agent which has that particular API and then go and remove that and then place it. So in that process you need to stop the entire agent process, right? So here in MCP it is not like that. It's like a server client different, right? So here we can see this is the client and these are the servers, different servers. If there is a fault in one server, you remove that particular server, debug it and then fix it back. So in that way the rest of the process keeps on continuing, right? So if you find another server, let's say there is another tool you want to complete, you want to fit into the agents, you bring that server and connect to the USB port. That's it. So it makes the process more simplified and it is scope for scalable, right? So you don't have to stop the agentic AI process in midway to debug. So the process can run and you just need to remove the server, debug it and then fit it back. So this makes this a very a very easy and standardized way of connecting AI agents to the external resources.